right, hello pre-calculus students. This is Mr. H here bringing you your Chapter 5, Section 2 notes. So today we're going to introduce you to a process that we are going to call verifying trig identities, and we're going to build off of the work that you did yesterday as we introduced you to the 8 fundamental identities and you began to do some work with those, all right? So let's begin by actually going back and talking a little bit about these fundamental identities. So we categorize them in 3 categories. We had our reciprocal identities, the ratio identities, and the Pythagorean identities. And we want to remember, as we talked about yesterday, those reciprocal identities could actually be rewritten, right? So we could take and kind of maneuver some things around. And so we actually end up with 6 different reciprocal identities, right? We had the cosecant we know is 1 over sine. Well, that can be manipulated to say sine is 1 over cosecant. And the same is true with all of our reciprocal identities, all right? Now, the other thing that we want to remind you of is with our Pythagorean identities, right? We could take each of these Pythagorean identities and we could do some manipulation of each one of them. And that actually opens the door to some other work that we can do with those identities. So let's take our first one, for example. So if we have sine squared theta plus cosine squared theta equals 1, right? Mr. H called that the great mathematical pickup line yesterday. We can maneuver some pieces around in this identity and create 2 more, right? So I could take and subtract cosine squared from each side, right? And that would then give us sine squared theta equals 1 minus cosine squared theta. Or we could take and subtract sine squared from each side, which would give us an identity that cosine squared theta equals 1 minus sine squared theta, right? And we could do that with each of our other Pythagorean identities as well. So if we do that with the 1 plus cotangent squared equals cosecant squared, right? Again, just subtracting each piece to the other side, we create more identities, all right? And again, finally, the same thing with our last Pythagorean identity. So again, it's important to remember that we have the 8 fundamental identities, but each of those identities can be rearranged around in some fashion to create other identities, all right? Now, these are the things that we are going to be utilizing today to verify trig identities, all right? So let me give you an example of what a problem is going to look like when we talk about verifying trig identities, all right? So here's our example. We could take a problem like this: sine squared theta minus 1 divided by secant squared theta minus 1 divided by secant squared theta is equal to sine squared theta minus sine squared theta. Now you'll look at this and go, well, this kind of looks like what we were doing yesterday with simplifying, but they've given us what the answer is, and that would be true, right? Yesterday we started with a problem like the left side of this identity, and we simplified it down to be the right side of the identity, all right? So that is the process of verifying an identity, is we are going to show the work, right? So we know what the answer is. We know that this equals sine squared theta. Our goal is to verify that. Can we show the work that demonstrates that, yes, this really is equal to sine squared theta, all right? Now, I'm going to show you some hints, some steps, some guidelines. Really not steps, but guidelines. There's not an exact process to these problems, but there are some overarching guidelines that we can follow, all right? So I would recommend that you pause the video here real quick and write these down, or listen carefully as you write them down and I kind of talk through each of these guidelines, okay? So the first thing that's most important here is the first identity, or the first guideline. It says work with one side of the equation at a time, all right? And it's often better to work with the more complicated side first, right? So if we take a look at this identity, and we'll actually show the work to this one on the next slide, but if we were to determine what we think is the more complicated side, I think everybody would agree that this side is more complicated than the right side. So in terms of verifying this identity, we're going to take and simplify this side down, knowing what we're trying to simplify it to, okay? Now, one thing that's really important here is we know what the finish line is in this problem, right? Our finish line here is going to be sine squared theta. So as we make decisions, as we listen to these other guidelines, we always want to keep our end in sight, right? Am I making decisions? Am I doing algebra or using identities that help me get closer to this? Okay, that's something important to keep in mind, okay? Now, number 2, you'll notice it says look for opportunities to factor an expression, add fractions, square a binomial, or create a denominator, all right? So ultimately what this is telling us is we are going to use algebra, right? These are all algebraic skills. These are all things that we've done in algebra throughout your time. We could go back to algebra 1 and geometry, right? We've factored, you've added fractions, you've squared things, right? Those algebra is the steps. They're kind of the rules of things that we can do with our identities, all right? Now, guideline number 3 says look for opportunities to use the fundamental identities, right? So just like yesterday when we were simplifying, we were noticing like, hey, this is an identity. I can simplify this down. So we would utilize those identities, and we're going to want to do that same thing again today. All right, now guideline number 4 says if the preceding guidelines do not help, then try converting all terms to sine and cosine. All right, I mentioned this yesterday in one of the simplifying problems, but sines and cosines, sine and cosine are our most versatile pieces of the identities that we have to work with, right? We mentioned yesterday that 6 of the 8 identities involve sine or cosine in some way. And so again, if you get stuck, just say, hey, I'm going to change everything to sine and cosine. And usually that then opens the door for some of these algebra steps, right? Sometimes we can cancel things, or we might say, oh, now there's some fractions I can add, right? Those are things that we want to keep in mind, all right? And I love this last guideline. Always try something, right? Even if you look at a problem, you're like, I don't really know where to begin, right? Just look at it and say, okay, algebraically, what could I do to this problem, right? And even as you go down those paths, again, like it says here, a dead end can provide insight. You can go, oh, okay, that didn't work, but in the process of that, I saw this that would work, okay? So the worst thing you can do in these problems is just to write it down and then stare at it, all right? Do something. Failure leads to success. So even if you hit a dead end, that eliminates a path, right? I'm always reminded of a quote from Thomas Edison when somebody asked him about inventing the light bulb. And they said, oh, congratulations on inventing a light bulb. And he said, no, I didn't invent a light bulb. I invented 1,000 ways not to invent a light bulb, right? And his point in that statement is that his failures, his 1,000 failures led to success. Now, you're not going to fail 1,000 times, but I do want to encourage you as you take a look at these problems, try something, all right? The only way you get better through these problems is practice. I'm going to make it look easy, but I have literally done thousands upon thousands of verifying trig identity problems in my career, both as a student and as a teacher. So I should make it look pretty easy, okay? But again, I just need to repeat, I've had a ton of practice, all right? With practice, you'll get there as well. All right, so let's actually get to the point of verifying this identity, and you'll see how we come back to some of these guidelines, all right? So here is that identity. Now, I'm actually going to use this problem to prove an important point, and that is that there is no one correct way to do this problem, right? Your job is to show how we get from the left side to the right side, right? That's your goal. Now, I don't care how many steps that takes. If it takes you 10 steps, it takes you 10 steps. All right. Somebody might do this problem a different way and it takes them 3 steps. All right. That doesn't mean that your 10-step process is wrong. Your 10 steps still verified that this is an identity. It's a true identity, right? These two things are equal. All right. And you might think, well, they did it faster. Well, I would argue that your 10 steps for you was faster than their 3 steps because you just didn't see the 3-step route, right? So again, really important to understand that there are multiple ways to do these problems. So even the examples that I'm going to do through this presentation, you might say, look at it and say, well, he could have done this. And you're right, there might be a different way for me to do this problem. I'm just showing you the ways that I first see it, okay? But you might see it a different route, right? So we might take different roads, but the goal is, do we end up at the same location? So in this problem, can we get from secant squared theta minus 1 over secant squared theta, and can we show a path that verifies that this is equal to sine squared theta? And when we get to sine squared theta, we're done, all right? So The first method that I'm going to use to solve this is when we first look at this, some of you might be looking at that numerator and saying, hey, secant squared theta minus 1. We've dealt with a lot of problems like this already, and anytime I see something squared and a plus 1 or a minus 1, there's a good chance that that is a Pythagorean identity, right? And if you look at your Pythagorean identities, you would be correct, right? We know that secant squared theta minus 1 is tangent squared theta. So let's just go ahead and substitute that in, right? So again, just like yesterday, we're going to show our work, and then we're going to explain what we did, right? So in this step, we've just changed secant squared theta minus 1 into tangent squared theta, right? We substituted that Pythagorean identity. Now I want you to notice that I have an equal sign here at the end of the problem. And that's again because I'm reminding myself, hey, I'm trying to get this to equal something. And what I want it to equal is sine squared theta. Now, if you want to write sine squared theta on the end of every one of these steps, that's fine. I don't do that just to save myself time, right? I can go back up here and remind myself of where I'm going, okay? All right, so we get to this point, you might go, well, we're really not any closer to sine squared theta, all right? Now, again, important to remember, hey, let's keep the end in sight, okay? And our end is sine squared theta. Well, I know that tangent and secant can both be changed into those really versatile pieces of sines and cosines. So let's go ahead and use our ratio identity with tangent, knowing that that's going to change into sine squared over cosine squared. And let's use our reciprocal identity with a secant, okay? So if we do that, right, again, it looks like this really complicated fraction, right? And you might seem like we're making it more complicated than we are simplifying it to sine squared, but sometimes that's a part of the process, right? So at this point, all I've done, I haven't even done any algebra in this problem. I've just done all substitution, right? I substituted a Pythagorean identity. Now we've substituted in the ratio identity, right? We know tangent is sine over cosine, so tangent squared is sine squared over cosine squared. We substitute in the reciprocal identity, all right? And then, well, anytime we have a fraction divided by a fraction, again, if I keep my end in sight, I don't have fractions. So let's go ahead and simplify this down by multiplying by the reciprocal, right? And I really like what happens here because when I look at that, if I multiply by the reciprocal, well, that now puts me in a situation where the cosine squareds cancel each other out. And hey, that's pretty nice because if we cancel out those cosine squareds, we have now turned all of this into sine squared theta, right? And that is what the right side of our problem equaled. So the key to these problems is I know what the answer is. The answer is sine squared theta. But again, when I look at your work on a quiz or a test, I want to see what was the process that you got to get to that point. All right, this up here is the real answer to this problem, not the last line. Okay. Now, I just want to use this example, and this is the only problem that we'll do this on, but I'm going to show you a second way that we could have done this problem. Okay, something different, but again, just to show that there are multiple roads to get to the same destination. Okay. So in this one, I'm going to start with actually some algebra. All right, if I go back to my original problem and I take a look at this and I go, hey, my end doesn't have a fraction in it, right? So I say, hey, let's go ahead and instead of doing the substitution with the Pythagorean identity, I might go, let's go ahead and actually substitute or go ahead and break this into two different fractions, right? So I could rewrite this to be secant squared theta over secant squared theta minus 1 over secant squared theta, right? A lot of times we try to get common denominators to combine fractions, but sometimes it might actually be helpful to break it into fractions, okay? And that's what I'm doing in this example, right? As I'm breaking this into two separate fractions that are still equivalent, they're still equal, right? We have common denominators. We could go ahead and combine those and go back to this. But now we might look at this and go, hey, there's a couple things we can do here, right? Well, I know that secant squared theta over secant squared theta is 1. And 1 over secant squared, well, that's a reciprocal identity, right? So we can go ahead and simplify this down a little bit by just reducing secant squared over secant squared to 1. 1 over secant squared is the reciprocal identity of cosine squared. And now you might look at this and go, hey, this kind of looks like a Pythagorean identity, right? We know that sine squared plus cosine squared equals 1, and one of its alternative forms is that sine squared equals 1 minus cosine squared. So I can go ahead and substitute that in, right? Those two are equal to each other, all right? This 1 minus cosine squared theta is equal to sine squared theta, and when I substitute that Pythagorean identity in, again, I have reached my final destination. Sine squared is equal to sine squared, all right? So both of these examples show you two different ways to get to the same point. Now, again, you might look at this and go, well, hey, that second route, that's a lot faster. It's not about doing it in the least amount of steps. It's about whatever route you see, all right? If you saw this one right off the bat, if as I walk through that problem, you're like, yeah, I saw that coming. Okay, that's faster than for you, than trying to figure out these 3 steps, okay? So again, the point of these problems is not to do it in the least amount of steps. It's just for you to show the path from one side of the identity to another, okay? So let's take a look at another example, all right? And again, you're going to notice that every problem is a little bit different, but we're utilizing the same guidelines, okay? So let's start with this problem. Oh, and I got a animation that's popped up here, so I apologize for that. So just ignore that for a little bit. So if I take a look at this problem, again, our first guideline has got to be what side are we going to start with? And the guideline is what is the more complicated side, right? So last time we worked with the left side and tried to make it look like the right. If I'm making the decision, which I am in the creation of this video, I'm going to say that this side looks a lot more complicated than the other side, all right? So that's the route that we're going to work with, okay? So as I analyze this right side, you might go, well, I can't substitute anything. There's one minus sign and one plus sign, but we don't have squared, so that's not a Pythagorean identity. There's really nothing else I can do, but, okay, in terms of substituting identities, I've got no road there. So as I look at this, it probably makes the most sense. I have addition in this side that I don't over here. So let's go ahead and get common denominators and let's add these fractions together. Let's see what happens if we do that. All right. So that's my first step. I'm going to get common denominators. So you'll see I multiplied top and bottom of the left fraction by 1 plus sine of theta. All right. And I multiplied top and bottom of the right fraction by 1 minus sine of theta. All right. And we got common denominators yesterday in one of our simplifying problems, so we're kind of utilizing that same skill here, all right? And you can see this time my equal sign is on the left side of my problem, right? Because I'm trying to work with the right side, all right? So we might look at that and go, okay, well, the whole point of getting common denominators was to go ahead and add these two together. So let's go ahead and do that, all right? So if I add those fractions together, the sine thetas cancel each other out, and the 1 plus the 1 gives me 2. Now, this is really important to kind of point out, right? We always want to keep our end in sight. So when I get this 2 in the numerator, I'm kind of excited about that because I have a 2 on the other side, right? So as I work with this problem, okay, I don't want to do anything to mess with that 2, all right? So now as I look at this, it's almost, okay, can I take this denominator and can I change that into secant squared theta? Okay. Well, hopefully as you look at this, you go, hey, 1 minus sine theta and 1 plus sine theta. Well, that's a difference of squares, right? So our difference of squares, if we go ahead and multiply those together, right, that's going to give us 1 minus sine squared theta, right? So I just multiply those denominators because they're a difference of squares, all right? And I kind of like the route that's going on here. So now you can already see our next step, right? Well, 1 minus sine squared, hopefully we recognize that as a Pythagorean identity, right? So I'm substituting 1 minus sine squared. I'm substituting cosine squared in for that, right? Because those are equal as I manipulate one of those Pythagorean identities, right? Well, if I have cosine in the denominator, right? Cosine in the denominator, that's the reciprocal of secant. So I go ahead and utilize my reciprocal identity, right? And I have now shown that 2 secant squared theta equals 2 secant squared theta, right? I have manipulated the right side of this identity to equal the left side, all right? And again, the work is the problem, right? The work is what we need to show, all right? So just another example here. Now, hopefully you notice that in the examples that we've done so far, most of these problems, if you find a quicker route, and not necessarily the fastest route, but a quicker route, they should not take you more than 7 or 8 steps, all right? If you're working a problem and you're on like step 10 and you're nowhere close to the end, I would recommend you restart and try something different, okay? None of the identities that I'm going to give you on a homework assignment, on a quiz, should really take you more than 10 steps. Now, you might take a really scenic route and maybe it takes more than 10 steps, but if you look back on your work, it's probably because you're kind of undoing something that you did and you ended up kind of making a loop or a circle in the middle of your work, right? So, again, keep that end in sight and work towards that, all right? So let's do one more example. And then I'm going to turn you loose with your homework assignment today, okay? All right, so here's our last example. In this problem, you're going to see right off the bat, if we use that first guideline, we should always start with the more complicated side. Well, this is a problem where both sides are kind of pretty much the same, right? There's really not one that's more complicated than the other. So if that's the case, in a problem like this one, we can actually work with both sides. All right, I'm going to work with my left side and my right side, and I'm going to see what happens there. Okay, so it really doesn't matter what side we start with. I'm going to start with the left side just because I see something there. I see that cotangent squared theta, and I see cosecant in the denominator. And I know that cotangent and cosecant are connected through one of the Pythagorean identities, all right? So that kind of opens the door for something for me. So I'm going to start on the left side, and I'm going to substitute in that Pythagorean identity, all right? So I have cosecant squared theta minus 1. Now, these two are really similar to each other, right? There's a lot of similarities here. And again, hopefully we're thinking algebraically. If I saw a problem like this one in an algebra problem, so if we just kind of take the trig part away, and you saw this as like x squared minus 1, kind of like when we were factoring yesterday, right? We'd go, oh, that's a difference of squares, right? I could factor that into x plus 1 and x minus 1. Well, that's the same thing that we can do in this problem, right? But instead of x's, we have cosecants. So I'm going to factor that numerator, because it's a difference of squares, into cosecant theta plus 1 and cosecant theta minus 1, right? If I FOILed these two, if I multiplied them together, right, because they're a difference of squares, the middle terms cancel out and I'm left with this, right? So we want to think about those algebraic patterns that you've used throughout your math career, all right? Now, when we factor that, that's really nice because cosecant of theta plus 1, I have it in the numerator and the denominator. Those cancel out, right? And this just reduces down to cosecant theta minus 1, okay? Now, there's really nothing else I can do on this side. So at this point, I'm going to stop there. But this does help me, right? I've simplified this side down. So now my goal is, hey, can I create this out of this, right? I'm going to now switch to the right side of this problem, all right? And I'm going to see if I can reduce that down to cosecant theta minus 1, all right? Now, if you're kind of being observant, you might remember a problem that we did earlier on this presentation. The very first problem, the second solution that I showed was, hey, we could break this into fractions. And that should jump out at you. It's a great idea, right? Because I have the subtraction in the numerator. Well, I need subtraction in the end, right? Sine over sine is 1, and 1 over sine is cosecant, right? So I'm like, hey, there's something I can work with here. So let's break that into two fractions, right? 1 over sine minus sine over sine. And then let's simplify. and use our reciprocal identity, right? 1 over sine is cosecant, sine over sine is 1. So I have now shown that the left side is equal to the right side by changing both of those into cosecant theta minus 1, right? And again, notice I did this problem in 5 steps, okay? Um, so again, the challenge with these problems is there's not one set way to do things. What we have is a process that we're going to work through. You've got some guidelines, and it's just going to take practice. Okay. So here's something that I want to encourage you to do in terms of practice. All right. I highly recommend that you look through the other examples in your textbook. So you can use the PDF pages for Chapter 5, Section 2, 5.2 on page 359. Now, I used a couple of the examples out of the textbook, but I didn't do examples 3, 4, 5, or 7. Now, if you watch this video and you're like, I'm feeling pretty good, you can probably move forward without looking at the actual examples. But if you get stuck on a problem, maybe look at examples 3, 4, 5, or 7 and see if there's something similar in those to the problem that you're working on. All right. Now, for some of you, this is going to come really easy to. All right. Your mind can see the past. You're kind of a creative problem solver. But for some of you, this is not going to come easy at first. All right. And the worst thing you could do is not do anything. All right. The best thing that you can do is practice, right? Do every homework problem. All right. Ask your neighbor. If you get stuck somewhere, just say, hey, what did you do to get started? Don't ask them how they did it. Just ask them how they got started. All right. Ask them, what'd you do on the first step? And then see if you can figure out the rest from there. All right. Or if you get, partway through a problem, just turn to your neighbor and say, hey, if you were here, what would you do? All right. And they might be able to kind of help you work through that. All right. And you can do a simple search on verifying trig identities on YouTube and see all kinds of other example problems worked out. So sometimes, again, just practice, practice, practice is going to be so important here. All right. So here is your homework assignment for the day. Now, again, I do want to point out we're going to look ahead at a quiz. We're going to do a couple more days of this, so that quiz is not going to be right away. But you want to make sure that each day you're getting a little bit better at this so that by the time our quiz over this does roll around, you're feeling pretty confident. All right, so just 4 problems in your assignment. Again, take the time and attempt every single problem. All right, and when we get back together in class, if you got stuck on any of these, we'll pick up on where you left off and see how you did, and we'll give you some more practice as well. All right, you guys have a great day. Appreciate your time watching, and we'll talk to you later.